Let's learn C with one project. In this video, we are going to create a featureful to-do list app on the command line using C. There will be options to add task, delete task, edit task, mark task as completed, and also list tasks. With this one project, you can learn the C topics like struct, input output, functions, pointers, for loops, while loops, if statement, switch statement, and most importantly, manual memory management. Well, the first 8 topics are covered in almost all tutorials. The manual memory management part is left out. But with this video, you can get an idea on the same in C, and we will be using it in the project. So the only requirement is basic programming knowledge in any language. So let's start writing code. We'll start off by creating a C file. I will just name it main.c. You can either have the extension capital letter or small letter. I will start by including some header files. Now we are including this to get the contents of get the functions and other contents from other C file or header file. So we will be including stdio.h, which is for standard input output, which manages the input and output. Then we need the stdlib.h for handling the manual memory management and stuff. And then we also need the string.h for handling strings. Now I'll write a basic C code, which is the basic structure of a C code. There will be a main function. So this main function is required in all the C and C++ programs. Now because it is an integer function, we need to return an integer, so I will return 0. This is the basic structure of a C program. Now we need to create the task model. So let us say, now inside this there should be a string task, and we also need a variable to check whether the task is completed or not. So it will be a boolean completed. So if it is completed, it will be true, otherwise it will be false. Now how can we do this in C? So in C there is a collective data type called struct, and that allows us to group together multiple variables of different types under a single name. So we can just create the structs right now. Now how to do that? We will do that outside this main function in here. So we use struct keyword and then the name of the struct. So it is task in this case. Now we can put the variables that come under this task structure inside this one. So there is no specific data type for string in C. So what we can do is we can use a character pointer. So pointer is created using this star sign, and then we'll just name the variable task. This represents the string task, and then there is also no boolean, but we can actually use it by including a header file called stdbool, but we will be using int for this one. So int completed. Now 1 represent true and 0 represent false. That's how we are going to take the convention. Now outside this, I'll just create a data type of the object, of the task object. So struct task, and then it should be a pointer. Now this pointer will hold all the different task models together. As default, we will set it to null. Now by setting this pointer to a null, no memory will be allocated, that is 0 bytes will be used. Now I'll also create another variable called length, which represents the number of tasks that are currently in this data type. Now as you can see, we'll need to always use this struct keyword whenever we use this task whenever we use this task. So to get rid of that, what can be done is we can remove this task from here, and we'll add it in the end, the name task. But also we'll have to use the keyword type def to use that. Now we can just remove this struct keyword, and this one is enough. Now I said something about something called pointers. Now what are pointers? So let's say this is our RAM or memory. Now in the memory there are let's say if there is something like 8 GB, each GB is made up of 1024 bytes, I mean megabytes, each MB is made up of 1024 kilobytes or KB, and each of these KB is made up of 1024 bytes. Then each of these bytes will be divided, and let this be 4 bytes, and each one of them will have a specific address or unique name. So it will be in the hexadecimal number system, and let us say that it is having a value of 1000. Then the next one will have a value of 1001. It's not the actual value, I'm just saying, and 1003. Now each of these numbers is what a pointer represents. So pointer represents the memory address of a variable. So in here, this pointer represents the memory address of this task, this character task. So now it is useful during manual memory allocation and on many other cases. It's a very important topic in C and C++. So in here, outside this main function, again, I'm just going to add some functions. One of them is a void add task. Now specifying using the keyword void means it is a null. That is, it doesn't return any value. It just performs some functions or performs some specific task. Now we'll create functions for listing the tasks. So list tasks, and then we'll also create 3 more functions. One of them is to mark completed. To mark a task as completed, then we need 2 more functions. One of them is to delete task and also edit task. Okay, I'll just rename this to just task. I don't want it to be plural. Now all the functions are created. Now we'll get into manual memory management. So in what manual memory management refers to is, it is the practice of explicitly allocating and deallocating memory for variables, data structures, and other objects. Now what this explicitly means is, the user itself will allocate and deallocate the amount of memory required for variables and stuff. So there are 3 main functions for allocating and 1 function for deallocating. There are functions called mallocate, callocate, and reallocate for allocation, and a function called free to free the memory or deallocate. Now mallocate allocate a block of memory of a specified size but does not initialize its content. So there are mallocate, reallocate, and callocate. To allocate, these all are to allocate, and to deallocate there is a function called free. Now what does this callocate does? It allocates memory for an array of elements and initializes all of them to 0, while the mallocate doesn't initialize any value. And the reallocate is used to change the amount of memory allocated for something, some object or variable. Now the free is used to release memory that is no longer needed. Now it is very important to release the memory when it is not needed. Otherwise there will be inefficient memory usage and some problems like memory leak. So it's a very crucial problem that we need to consider. We need to get a parameter or argument into this function to add the text, or whatever text should be added as a task, we want to take it as an argument. So we'll use the const keyword to specify that it will not change. It is a character pointer of task, just the same data type as we used as a member variable for the struct task. Now in here I'm just going to access the tasks, this tasks pointer, and we need to reallocate the memory. That is, we need to assign more memory to the pointer, because as default the amount of memory allocated is 0. To add a task we need to assign more, we need to allocate more memory. So it is the data type is a task pointer, so we'll pass it inside this parenthesis, and we call the reallocate function. Reallocate, we want to reallocate the memory of the tasks, and then we need to pass the next argument is the new size, or the size that is required. It will be equal to the length plus 1 into size of the task structure, because the data type stores objects of the type of this struct. So if this task structure needs a memory of 4 bytes, then it will be equal to the length plus 1 into 4. Now when we start, the length is equal to 0 because there is no task inside the pointer. So this will return 0 plus 1 into 4, that is 4. Now when we already have a task, and then we need to add a new task, then it will be equal to 2 into size of task. I'm just considering the size of task to be 4. It is not actually 4. It will be depending on the length of the string that we pass in. dot length, these tasks represent this pointer again. It will be equal to character pointer because our task is of the type character pointer, and we are going to allocate a memory. This time we are not reallocating but allocating, and then we need to check the length of the string to find the size or to find the memory that it needs. We use the strlen function to check the length or the number of characters available in a string. We want to check it of the task variable itself, and then to that we will need to add 1, because in the end, after every string, in the end a /0 will be added, which represents end of the string. So for that slash string we need to we are adding this 1. Now we need to we have one more argument or one more member variable for this task structure. In here we are setting this character pointer task. Now we need to set this completed variable also. What we can do is we can access the tasks again, and we need to pass in the length dot completed, task dot length dot completed. Now as default, when we start, the length is equal to 0, so it will just set the first task to this value, and then the first task's completed variable to 0. Because 0 is false, as default the task will not be completed. Now we need to copy the content of this task const character task into this task field of this struct. So we use the strcpy or strcopy or string copy function of the string.h. So strcpy, which stands for string copy, and then whichever string we want to whichever object we want to copy the string to is the first argument. We want to copy it into the struct data type task, and what string should be copied? We should copy the task that we pass in as an argument in here. So with this we are actually setting the value of the argument to the field of the struct. Now we'll increase the length by 1 because we added a string. So from 0 it will be set to 1 in the first case, and in the end I will just print f. This is how to print in C, task added, because a task will be added if all these are performed correctly. With this, the add tasks function is done. Now we need to list all the tasks, so we are going to get into that. No, we doesn't need any arguments because we are just going to loop through this task struct and print them all. I'm just going to create a for loop because we need to go through all the items of this pointer and print them all. So for, I'm just going to initialize a variable, control variable called I to 0, and then it should be, the length should be less than or I should be less than the length, otherwise there we will be going out of the bounds and there will be an error or exception. Now we will keep on increasing the value. Now if tasks I, if the ith object of the task pointer is, if the field completed is equal to 1, or if it is actually completed, then the status will be equal to D, which stands for done. Now to use this we need to create a variable in here, character status. We are not going to initialize it in here because either it will be going through this if statement or through this else if or through this else statement, because the value of the completed can only be 1 or 0. If the task is completed, we set the status to D, and if it is not completed, that is else, we set it to N, which stands for not done. Now inside this for loop, we need to print all the tasks also. So I'm just going to show you how to format a string in C. Now to print an integer in C, we need to use %d, and then to print a string in C, we need to use %s. To print a character in C, we need to use %c. Now what this means is, and /n is to go to the new line. Now we can put the variables in here. First, the integer variable will be I plus 1 because the I starts from 0, but for a user it is more convenient to start the index from 1. That's why I'm showing I plus 1 in here. Now we need a string which will be the tasks I dot task, because the task is a character pointer or a string. Now we also need a character which is this status variable, status. Now how this will be formatted is, it will be formatted in the same manner. First the number or the index plus 1 will be shown, then there will be a dot, after a space the string will be shown, and after a space inside square brackets the character will also be shown. Now after each loop is completed we will go into the new line because we are putting slash n. Now we need an argument to this to check which task we need to delete or which task we need to mark as completed. So we use the index to check which one we need to mark as completed. Now the argument that we are taking is not the index that starts from 0, but the index that the user can see when he lists the task. So the first one will be 1. So if the user passes an argument of 1, then the first task that we have will be accessed. So now we need to check if the index is valid. Obviously the index should be less than or equal to the length of the tasks pointer or the number of tasks available, and it should be greater than 0. When we are using the index that starts with 0, we actually put it's greater than or equal to 0, but this time we want the index to start from 1. That's why I'm putting just greater than. Similarly, if we were using the index starting with 0, we will not be putting this equal to in here, but this time I want it because again we are starting with the index 1. Now we are going to set the completed to true. So tasks index minus 1, because the programming language starts the index from 0, but we want it to start from 1, and that's the argument. So we need to subtract 1 from that, and we set the member variable completed to 1, which stands for true. Now we will just printf task marked as completed, and I will also put a new line. Now we have an if statement, so we'll just also put the else statement, which will be invalid index, because this checks whether the index is valid. So in here I'm just going to print invalid index, and also I'm just going to go into the new line. Now we will get into the delete task function. So again we will check if the index is valid, because we need to delete a specific task, so we need to access it using the index. Again we will pass in int index as the argument. Again, as I said, the index that we mean here is the one that starts from 1. So we use the same if statement to check if the index is valid, and also I'll just create an else statement in here and print invalid index if that's not the case. Also leave a new line, put slash n to go to the next line. Now we need to reduce the index by 1, because, or I think the more understandable one for this case is index is equal index minus 1, because we are just doing it one time. So the reason why we are doing this is, again, we are starting from the index 1, but the compiler wants it to start from 0. So if we give the index as 1, it will actually access the 0th index of the tasks pointer. Now we need to free a memory, because we are removing an item, so unwanted memory is not needed. So it takes in an argument task, or whichever memory we need to free. So tasks index dot task, we are removing that specific string task from the task structure. Okay, and then we will loop through again, use the for loop. There will be a control variable I. We will set it to not 0 index. So I is equal to index when we start, and then I less than the length of the string or the number of tasks, and again I plus plus, but it should be I less than length minus 1. We are using this for loop to shift the remaining tasks to fill the gap. Let's say there are 5 tasks. Let this be A, B, C, D, and E. So if we delete this cth task, then there should a shifting should take place because this is removed. These two, the ones that come after that one, should shift to backward phases. That's why we are setting the control variable to index instead of 0 and length minus 1, because the length in here is equal to 5, but in here it is equal to 5, but the index will be equal to 5 minus 1. The maximum index is 4. because index starts from 0, 1, 2, 3, 4. That's why we are setting it to index -1 and I plus plus. Now what we are going to do is we are accessing that specific task of ith element and setting it to the I plus 1 element. So tasks I plus 1. So now we need to decrease the length because one of the task is deleted, so the length is decreased by 1. So we use this length minus minus to do that. Now we need to reallocate the memory to adjust the size by reducing the size. So again we will use the tasks variable will be set to the data type is task, just the same way that we did in the add task function. So I'll just copy this one and make some changes to that. In here I'll just paste that. Now what all should be changed is in here, instead of the length -1, length +1, I'll just remove everything related to that, and we'll just multiply the length by the size of task. Oh, I think there is parenthesis problem. Okay, we are multiplying the length of the array by the size of task. And let me check what the error is expected as an expected bracket. So I think, okay, now the error is fixed. Now we are going to get into the edit task function, which is the last function that we are going to write. Again, I'll just copy everything from the delete task because we need the we need to check whether the index is valid and also the else statement. So I'm just going to copy everything, and everything inside this if statement is removed. In here the invalid index is kept the same. Now we will get into the same, but there is an error in here, and the error is because we are using this index variable but it is not defined anywhere. So we need an argument because we need to the user should specify whichever task we need to edit. Now we are going to reduce the index by 1. Again, the same reason why we did in the delete task. Now we are going to create a new task. It will be the edited task. So I'll just rename this to edited task. It is again a character pointer because strings, and we need to reallocate a memory for that. So it's a character pointer, the task character pointer task, and then we are going to reallocate memory for that, or whichever pointer we need to change the amount of memory reserved for as the first argument, and the second one is the size that we want to set it to. So we want to change the size of the tasks of an object of the tasks pointer based on the index, and we are going to change the task member of that struct, and we want to set it into strlen, which is the length of the, which will return the length of the string, and passing task +1. Now this we are not multiplying it by any number because the amount of bytes reserved for a string will be equal to the amount of characters in that, because each character takes in each character requires 1 byte. Now there is an error because we need to also pass in the edited task. So const character pointer edited task. Okay, it's the same variable name, so I'll just change that just to task. Okay, now that error will be fixed. Now we need to check if the edited task is null. If that is the case, I mean not null, if that's the case only we need to allocate memory and all, otherwise, or if that's the case only we need to change the value in the task, otherwise we'll just create an else and print memory allocation failed. If the edited task is not equal to null, then we'll do something, otherwise we'll just printf memory allocation failed. In most of the cases it will not fail, but just for checking we are doing that. Now we are going to access the tasks index.task and set it to the new edited task. So it will be set to the edited task. So we also need to copy the string. Just by doing this will not work. We need to copy the value to the member variable of the struct, just like we did in the add task function. So I'll just copy this str copy line and paste in the edit task under this tasks dot under this. Okay, now one more, we'll just, with this everything will be done, and I'll just print it task updated successfully. Now we will in the main function, I'm just going to print something, and it's going to be options. Now we need many options to choose from for the user, and there should be options to add task, list task, mark as completed, edit task, or delete task. So I'll just print up everything right now. So first one will be add a task /n. I will be adding /n after everything. Now we can just test this out. So gcc is the compiler that we are using, gcc, then the name of the file main.c -o, and the name that we specify after this -o will be the name of the executable. So I specified it to be program. Now there is an error because I think I have used print somewhere instead of printf, so it's in the main.c 34th line. And here I am using printf, I mean print. So I'll just delete that. I'll clear the terminal and I will run it again. Now we have a program.exe generated. Now to run that, dot slash just the name, and with that we are printing add a task, list all tasks, mark as complete, edit task, delete task, and exit. Create a loop that runs. So in the main function we'll create a loop while. Now what should we pass inside this? So what I can do is, because there is no boolean in C, I will use an integer again. So I'll set the name of the variable to running, and as default I will set it to 1. As long as it is 1, it is true. So while running, now we need to check for some inputs. So I will just print f enter choice, and we have some choices. They can be 1, 2, 3, 4, 5, or 6. Now this 1 stands for adding tasks, 2 for listing tasks, and so on. Now after that we need to take in an integer input from the user. So we use the function scanf to take in integer inputs. So the data type is integer, so we need %d, because this scanf support other data types also, but for the string we will be using another function. Now we need to pass in the pointer of some variable. So in order to use a variable, I'll just create a variable called choice, and yeah, I'm not going to initialize it with any value. Now in here it is I'll just close it. In here a pointer is needed. We can see that a pointer is needed. Now the way we get the address or pointer of a variable is by using this sign. So this is the address of sign. So we need to get the address of the choice variable. With this we are accessing the pointer or the address of the choice variable. So now we will create a switch case or we'll create a switch statement. So switch. Now we need to check what the value of the choice variable is. So switch choice. Inside that there will be 6 cases. So for each one of these. So I'm just going to write all the cases. Case 1. Okay, now all the 6 cases are created. Now after that we also need one more which is for the default case. If the choice is none of these, now we'll just write what the default result will be. So if the user gives an input that is not 1 or 2, 3, 4 or 5 or 6, then we need to print invalid choice, because that choice is not defined in our program. So we'll leave a line and I'll just break out. For the default one, break is not actually required, because obviously it is the last one. So just after doing this it will go into the next line, but we'll just put it there. Now the first case is for adding a task. So what will we do inside that? Now we'll just go into the function, and there is an argument called const character pointer task, or the string should be passed in as an argument. So that string will be given by the user as an input. So we need a variable to store the string, and also we need to copy it to the struct type or pointer. So in here I'm just going to printf enter task, and I'm not going to leave a new line. After entering the task, I will just call the get character function. So this function is used to consume the new line character left in the input buffer, and then we use the fgets function to use the string input for the string inputs. Fgets function, it is part of the stdio file itself. So now we need to pass in a character pointer buffer. So we need an input, whatever it should be a character pointer, so we need to create that variable in here. So character pointer task input, this is the input that we take in here. I'll just pass in the variable because there should be a character pointer there. Now we want the maximum number of characters allowed for the input. It will be equal to the amount of characters that the task input contains. So size of task input, because each character takes 1 bytes, so the size of so the amount of bytes required will be equal to the length of the string. Now the next one is the file restrict file, which will be std in. Now we need to set the value of the task input, or we need to remove the trailing new line, that is the /n character we need to remove. So task input strc, we use the strspan function, strspn function, and then in the function we need to pass in 2 arguments. One of them is a string, which is the task input string, and then the next argument is again a pointer, but the value which we want to remove. So it's a /n or the new line character that we want to remove, so just pass in there, and I'm just going to set it to /o, which is for end of string. And we will call the add task function and pass in task input as a parameter, because it requires a character pointer string as a parameter. So the first case is done, which is the add task function. Now in the list task, we just need to call the list task function. So before that, I just forgot to add the break in here. So after every case, break is needed, so don't forget that. Now in the case 2, it is for listing all the tasks. We doesn't have to get any input and all. So I'll just call the list task functions, and it will print all the tasks. Again, we need to break out of the switch case ladder. Now for the third case, which is for mark as complete, this time we need to enter the index as an argument to check which task we need to mark as complete, because in the mark completed function there is an argument called index. It is an integer index. We need to create another variable for that. So I'll just name it index input, because it's the input of the integer index. Now in the third case, we are going to get a value from the user using input and just assign that value. So I'm just going to print f enter index. Just enter index is enough, and then we need to scanf. For this one, scanf is enough. So now in the scanf itself, it's an integer, so we can just use that one. Again, %d, because the value type is an integer, and it's a pointer again, so we'll pass the reference of index input, just like we pass the reference of the choice in here. Now after that, we'll just call the mark completed function, and we need to pass in the index input as the argument or the index, and then we will break out of the case again, break switch again. Now the fourth case, which is for editing task, we'll need to get the index and also the task or the edited task, because in the edit task there are 2 arguments, index and a task string. So we'll use the same index input and task input variables for this one also, because we don't need to create new variables and use simply waste memory. So I'm just going to print enter index, and then we need to scanf or input that. Again, data type is integer, so %d reference of index input. I will print enter task or enter edited task, maybe. Okay, enter edited task. Now we'll need to again get the character, just like I'll just copy everything that we did in here. All these 2 lines should be copied, and I'll just paste it in here. Now because it's for the editing, we need to call the edit task function, and it takes in index and as a string. So index will be index input, and the other one will be task input, that is the string will be equal to task input. Now the fifth one is for deleting the task. So for this one we also need the index. So enter index, then we need to scanf the index, d for integer, reference of the variable index input. Now we will call the delete task function and pass in the variable delete task and pass in the index, which is index input. Again we need to break, I forgot to break out from the edit one. In here I'm just going to call break. Now for the case 6 also we need, now let me check the case 6, it's for exiting. We can just set the value of the running variable to 0 and this loop will stop running. So obviously it is the last bit of the code, so there's nothing else to do, that is the code will stop running. So we can set the running to 0, because as long as the running is true, only the loop is running. So in here I'm just going to break. We can just remove everything from the memory, so free tasks. Now whenever we are using manual memory management, it is very important to free the memory, otherwise there will be memory leaks. Let's compile it again using the same command. It's compiled successfully. Let's run it /program. Now it is asking for our input. Let's add a task by clicking 1. Now we can add a task. So okay, now there is a problem here. While creating the task input pointer, we'll have to specify the amount of characters that it can hold. So we can just set it to 100. So maximum 100 characters can be holded. In here we are copying it to the tasks length.task, but instead it should be to that specific index. So with this, I think the program is complete, and I hope you learned a lot about C. You learned about manual memory management and all. If you did, please like, share and subscribe.